This class we're going to discuss how to factor harder trinomials where the a value is not equal to 1, as well as how to simplify factorable fractions, which means you're going to take rational expressions that are in standard form on the numerator and the denominator, and we're going to simplify them, multiply them, and divide them. Now that we've mastered factoring simple trinomials where a is equal to 1, let's move on to harder trinomials. So what makes a trinomial harder? Like I just said, the a value will not be equal to 1, and you cannot common factor it to make it 1. So my question here is, which one is a complex trinomial? And when I say complex, I mean hard, I mean difficult, I mean a not equal to 1. So obviously this one is simple. Looking at this one, I have 3, -19, and -14. So this is a hard or complex trinomial. And looking at my third one, I have -3, -9, and +12. I also have too many x's, but there's common factors here. So always getting that leading term without a negative. So I'm going to factor out -3. I can factor out an x, and I'm left with x squared plus 3x minus 4. So the same as the first one, just in disguise. So this one is actually simple as well. Just have to look a little more carefully. So I keep saying harder and complex, like this is going to be a really big challenge. They're not that much harder. There's just a little more work. And I'm going to use a cheat or a trick that is kind of based in decomposition, which is one of the methods, but it's very time consuming. So I find that this trick is nice and fast. So that's what I'm going to show you. But if you have another way of doing it, by all means, go for it. So we're going to look at 2x squared plus 7x plus 6. First step, always, always, always common factor. If you don't common factor, this thing doesn't work. So I look up here, 2, 7, and 6. Nothing goes into all three of those. So this cannot be common factored. So I can proceed now. So we're going to do the same thing we did before. My AC line and my B line. AC is a product, B is a sum. And now be careful, when I say AC, it means A times C. So when A was 1, we just looked at the last number, but now we have to pay attention to the leading coefficient as well. So the AC line is something that multiplies to 12. And the B line is going to be the same two numbers adding to 7. So you can think about it, you've got 12 and 1, you've got 6 and 2, no good, no good, and you've got 3 and 4. And those work for you. Everything's positive, so both factors will be positive. Okay, so I've found my factors. So number 2, write them as denominators of two fractions with a numerator of ax. So I'm looking here. A is 2. So I'm going to write 2x over 3, which is one of my factors. And I'm going to write 2x, ax, over 4. I'm going to make these into binomials in a second. So I've done this step. Now, reduce the fractions if you can. So we're just going to act like 2/3. Can 2/3 be reduced? No. So I'm going to leave that one. And I'm going to look at my second fraction. It's like 2/4. Can 2/4 be reduced? Yeah, that can be changed into 1/2, right? Or 1x over 2. So these are your binomials, and the way it goes is you write down the first numerator, 2x, and the denominator plus 3. I wrote down plus because it was a positive 3 denominator, and I look to my second fraction, and I'm going to look at this one because I reduced it, x plus 2. Now, last step, check your answer. So use FOIL to go back. 2x times x is 2x squared. Outside is 4x, inside is 3x, plus 7x. And last is 2 times 3, which is 6. So we know that's correct. Now we're just going to do lots and lots of examples. Number 1. And I'm going to write common factor because it has to be your first step. Oops, come here, there we go. I can't for number one, so that's fine. My AC and my B. So I need to multiply to 2 times 5, which is 10. And I need to add to 11. So two numbers that multiply to 10 and add to 11. 10 and 1. Satisfy it, both things. Okay. So the second step, the weird trick, and you only do this trick if a is not equal to 1. If this had just been a simple one, you would stop and the answer would be x plus 10, x plus 1. But it's not. So we write down ax twice as numerators, and we write down our two factors that we solve for, 10 and 1. Now, we're going to go through, and if we can reduce the fraction, we will. 2 over 1 doesn't reduce, but 2 over 10 could be 1 over 5. And then we're going to write that down as our answer. So our first binomial is the numerator plus the denominator, and our second binomial, numerator plus denominator. And that's your answer. And make sure you check it. Okay, number 2, our AC line and our B line. So we're looking to multiply to 15, 5 times 3, but also combine to negative 8. So I know that both of my factors will be negative, just because B is negative and AC is positive. So I'm going to sneak these in. How do I factors of 15 that make 8? Not 15 and 1, has to be 5 and 3. Okay, so far so good. Write down AX twice. So taking that A value and just putting an X beside it, and then writing down your two factors, negative 5 and negative 3. I can oh, this could be 1. This could be 1. Noticing that negative sign is going to stay there, and I can't reduce 5 over negative 3. So my first binomial is going to be x minus 1, and my second binomial will be 5x minus 3. Continuing. Oops, that should be a plus sign. Sorry, it's too messy. Back it up, buttercup. There we go. So we're looking to do 7 times 5 is 35. And we need to get to negative 12. Factors of 35, and they're both going to be negative from the looks of it. Factors of 35 are 35 and 1, which doesn't work, and 7 and 5. So interesting in that we kind of started with 7 and 5, and we came out with 7 and 5, and that happens sometimes, but they are separate. So okay, we're going to do 7 times 5, 7 plus 5, but because the product is positive and the sum is negative, they must both be negative. And same thing. AX at the top of two fractions, the factors I just found as the denominators. Let's go ocean. Simplify if you can. Oops, sorry. Try that again. Simplify if you can. That's a 1. That can be a 1. 7x minus 5 won't change. So once again, I have x minus 1. This time to 7x minus 5. Continuing. Checking for common factoring. It's the most common thing I see. People don't do the common factoring, so I always try to harp in it. All right. Okay, so just going a little more quickly. Okay, so I need to make negative 12. So remember that when C is negative, I kind of think of it more as how far apart are the two factors instead of what do they add to. So I need factors of 12 that are 4 apart. You can think of it any way you want. That's how it works for me. So I know it's 12 and 1. Those are 11 apart. And then I go 6 and 2. Those are 4 apart, so I can stop. And I just need to know, how do I make a positive 4 with the 6 and the 2? If the 2 is negative. And we're going to do the same thing. Write down AX over your two factors. Okay, 4 over 6 can be 2 over 3. And 4 over negative 2 can be 2 over negative 1. So this time both of our binomials changed. 2x plus 3, 2x minus 1. And remembering, you can always just check your answer if you're not sure. Number 5, big numbers. I hate big numbers, so I always kind of look for a common factor right away. Big numbers that are all divisible by 5. So let's start by doing this, common factoring out of 5, and see what we're left with. 5x squared plus 9x minus 2. And this binomial is what we're going to work with. I'm sorry, trinomial is what we're going to work with. We're just going to ignore the 5 outside. So we're going to do all the stuff with the things in brackets. So I need to multiply to negative 10, 5 times negative 2, and I need to add to positive 9. Okay, so once again, because C is negative, or AC is negative, I know that I'm thinking about things that are apart as opposed to adding to, a difference instead of a sum. And 10 and 1 are 9 apart. And it's going to be positive 9, which means I need one of my factors to be negative, and it has to be the 1. So continuing on, using this A value, AX twice, my two factors that I just found, and reducing if you can. Nothing can be done with the second one. Now, don't forget, when you started this, you did a common factor, so it has to be in your answer as well. And we're going to have x plus 2, 5x minus 1. Okay, last one. Kind of gross numbers again, all divisible by 3. Leaving behind 2x squared minus 11x minus 6. And they just come faster and faster as you do these. And if it's something that you're really stumped by, just start listing the factor pairs to see what makes what. Okay, I need to multiply to negative 12, and I need to add to negative 11. My AC line is negative, so I'm looking for factors of 12 that are 11 apart. And that's only 12 and 1. And I need it to be negative, so the bigger absolute value will be negative. Going on to the trick part. Reducing if you can. Can't reduce the second one, remembering to bring down whatever you common factored out for your answer. Now that we've covered all the different ways we're going to factor polynomials, let's throw them into fractions and see what we can do there. So when we talk about algebraic fractions, we're talking about rational expressions. I'm using those terms interchangeably. So the things I want you to think about, always first, common factoring. You might have to use difference of squares. You might be looking at trinomials that you have to use the factoring that we've done, product sum, or your own way. And you might have things like numbers that you have reduced just by reducing fractions, or you would have exponents that you might have to reduce with exponent loss. So at the end of the day, I want you to take something like this and turn it into something like that. These are epic, so just bear with me. So first we're going to start with simplifying fractions. So we're going to common factor first. And when I say don't push the math, I mean don't try and make things equal to each other that are not equal to each other. On the other side, if you go through and you have nothing canceling, you've just factored and nothing changed, double check your math. All right, so let's look at this example here. We have a numerator and a denominator, n and d. So first I'm going to factor the numerator. And I see that it's x squared minus 12x plus 32. So I need things that multiply to 32 and add to negative 12. So I know that they're both could be negative. I can make 32 with 8 and 4, and conveniently, if they're negative 8 and negative 4, they combine to negative 12. And because this is a simple trinomial, where a is equal to 1, I'm done. You don't have to do the extra step that we do with the harder trinomials. And looking at the denominator, x squared minus 64, already I see a negative sign. I don't see a b term, so I'm thinking in my head this is difference of squares. So how to factor that? The root of x squared is x, and the root of 64 is 8, and then you just go 1 subtracted, 1 added. So when I combine this fraction in the factored form, I keep leaving off these brackets, there we go. We're going to have x minus 8, x minus 4, over x minus 8, x plus 8. Okay, and then we're just canceling. Anything the same, exactly the same, can go. So my final answer is this. That's the simplified fraction. Now, a lot of people will try and push this and be like, well, I can cancel the x's and then have negative 4 over 8, and then I can have negative 1/2. This only works if x is 0. If x is any other number or anything, it's not going to work out. So you can't do that. You can't make it a situation that only works for one value of x. So just, if you need to, keep the brackets on to prevent yourself from doing that, and recognizing that this binomial doesn't have anything in common with this binomial. So let me just quickly put a big X through this. We're going to work our way through a couple of examples. So I look at my number 1 here, and I see that the a value is 3. So it's looking like a harder trinomial. I double check. There's nothing I can common factor. So yeah, for the numerator, it's going to be one of those more complex ones. So let's start with that. Remembering you need an AC line. So I need two factors that are going to multiply to 3 times negative 10, which is negative 30. And I have a B line where the same two factors are going to combine to negative 13. So 3 and 10 are tempting, but watch the math. It won't work out. This one's actually going to be negative 15 and 2. And there's only ever one set of factors that work in these. Okay, so we're going to go on with our trick. Write down the a value and an x twice. And then we put negative 15 under one and 2 under the other. We reduce each fraction if we can. Switch to another color. This could be a 1 and this could be a negative 5, but my second fraction I can't reduce. So for the numerator, I'm going to have x minus 5, 3x plus 2 as the factored form. Looking at the denominator, I'm going to rearrange it. Negative x squared in descending order plus 4x plus 5 I'm going to factor out the negative because I don't like my leading term to be negative, which will change the sign of everything. And then it's a simple trinomial. 5 only can be made with 5 and 1. So my AC line is negative 5. My B line is negative 4. I need factors of 5 that combine to negative 4, or are 4 apart rather. So x minus 5, x plus 1. But remember, we had that negative in front. So it's kind of like cheating here. I'm going to put a box around that so it's easier to see. This is my factored form of that fraction. And now I'm going to do my canceling. So I can cancel x minus 5, top and bottom, and then I'm going to rewrite my answer. I'm going to throw the negative up top. I'm not going to distribute it. You can if you want to. Likewise, the negative where it is doesn't really matter. I just find it easiest to see when it's up top. So this is my final answer for that simplification. Looking at number 2. In the numerator, I can only common factor. Or at least I think I can. I'll start with it. So I see that I have enough x's in the second term to take out x squared. That will leave behind x minus 2. In the denominator, once again, I see that negative sign. I see a couple of squares. So I'm going to do the difference of squares shortcut. And I'm going to have the denominator factor 2, x plus 2, x minus 2. I combine my fraction, numerator over denominator, both factored. Any identical things can cancel. I can't deal with this x squared. I can't do anything with this x plus 2. My final answer is x squared over x plus 2. And there's the 2 answers in red boxes. Okay, so now we're going to ramp it up a bit, and we're going to start by multiplying factorable fractions. So this is no different. You're just doing more factoring. You have 2 numerators and 2 denominators. Remembering for fraction multiplication, we would be doing top times top, numerator times numerator, denominator times denominator. So when you do that, if you didn't factor it, you'd be doing some massive multiplication. So factor first and cancel and see if things are easier. And the last point here is don't get tempted by cross multiplication. Okay, fraction multiplication is just straight across. So we'll label our parts. This time I have n1 d1, n2 d2. And I'm going to factor everything and recombine it. n1. Moving a little quicker, this is a simple trinomial. I need to make 24 and add to 11. 8 and 3 are my choices, and I'm done. Looking at denominator 1, it looks like common factoring. I can take out a 6, I can take out x squared, and this is going to leave x plus 3. Looking at numerator 2, this is also common factoring. I can take out 2x squared, and this is going to leave x plus 1. And on denominator 2, I have to multiply to negative 24 and be 5 apart, so I'm looking at 8 and 3 again, but this time, in order to get a positive 5, the 8 must be positive, and the 3 must be negative. Okay, so I'm going to combine everything onto my fraction. So numerator 1 times numerator 2, and I can just smash them all together. So for numerator 1, x plus 3, x plus 8, numerator 2, 2x squared, but I'm going to put that in front just out of habit. That's fine, they can be anywhere, as long as we're all on the top of the fraction. And then I'm going to put that over denominator 1, and denominator 2. Okay, red pen out for canceling. We can cancel in a rainbow pen today. Those go. Those are the same. X plus 1, x plus 3, two different things. X squared over x squared is equivalent to 1. 2 over 6 is equivalent to 1 over 3. So my final answer over here, over here is going to be the leftovers. So I have x plus 1 on the top. And on the bottom, I have a 3, x minus 3. And I would leave it like that. This is factored form. This is the most useful form. It tells you where the asymptotes are. If you're graphing, it tells you a lot of where your intercepts are. It's the best way to leave it. If you turn this into, distribute the 3 and make it x plus 1 over 3x minus 9, you'll also get credit for that question. So we're going to do a couple of practice ones. We need a lot of room, so I'm taking a couple pages for this. Numerator 1, denominator 1, numerator 2, denominator 2. So looking at numerator 1, looks complex, but it has a common factor, so you can take out 2. So do that. X squared minus 2x minus 3. And suddenly that's factorable. I need factors that make minus 3 multiply to minus 3 and are going to combine to negative 2 by addition. There we go. Denominator 1, common factoring. Take out an x. X minus 3. Numerator 2 is also common factoring. This time I can take out x squared and end with x minus 4. And denominator 2 looks hard, but 4 is factored out and leaves x squared minus x minus 2, which is simple to factor. Don't forget the 4 in front. X minus 2, x plus 1. Combining everything on the front, numerator 1 turns into 2, x minus 3, 1. Oh, I'm going to put the x squared here, even though I would have liked it in the front. I just didn't see it, and I wrote it down. So that's n1 and n2, all multiplied together, and they're going to be over, okay, x onto x minus 3, and I'm going to put the 4 in front just so I don't lose it, from denominator 2, and then I have x minus 2, x plus 1. And it's so easy to make a mistake in these, so rough work, rough work. Okay, x minus 3 can cancel x minus 3, x plus 1 can cancel, x plus 1. The other binomials, there's nothing else I can do. 2 over 4 is 1 over 2. X squared over x is just x in the numerator, so I'm feeling pretty good about this. And I look across the top, don't drop anything. X onto x minus 4 over 2 onto x minus 2. We'll do another example of these. Okay, numerator 1, denominator 1, numerator 2, denominator 2. Back to black. There we go. Looking at n1, this is going to be one of the longer ones because I can't factor anything out. So my AC line, I need to multiply to negative 12, and I need to, for my B line, combine to negative 4. So my factors that will make that true, who's 4 apart, 6 and 2. And if 6 is negative, that will work out with the addition, the B line. Okay, so then you take that trick, write down AX twice. Underneath it, you put your factors, and you do any canceling that you can. So 4 over 2 is like 2 over 1, and 4 over negative 6 is like 2 over negative 3. And my binomials are 2x minus 3 and 2x plus 1. And remember, you can always check if you've done this correctly. Do a quick expansion and see if you get back to that numerator 1. For denominator 1, difference of squares. First square is x squared. The root of that is x. Second square is 1. The root of that is 1. So moving quickly with this, x plus 1, x minus 1. Numerator 2. Looks simple, but there's a negative in front. Factor that out. Changes the sign of everything in there. And if you factor that, negative stays in front. X minus 2, x plus 1. And denominator 2, not as awesome. Once again, it's going to be one of these longer ones. We're once again going to multiply our AC line. 2 times negative 6, we need to make negative 12. And our B line, and we need to be 1 apart. So we're looking at 3 and 4. In order to make them combine to negative 1, we need the 4 to be negative. Okay, so we do our trick. Looking up at D2, A value is 2, write it with an X. Over 3, over 4. Can't cancel anything in the first fraction. 2 over negative 4 is the same as 1 over negative 2. And this guy factoring will be 2x plus 3. Oh, that's irritating. And x minus 2. Okay, so I'm going to try and take this over into the blue area to continue on. So I'm going to put everything together from the numerator. I have numerator 1 is 2x minus 3, 2x plus 1. And numerator 2, there's a negative. I'm going to put that in front so I don't lose it. X minus 2, x plus 1. And I'm going to put that entire thing over denominator 1 times denominator 2. X plus 1, x minus 1, 2x plus 3, x minus 2. Okay, some things cancel, perhaps not as much as we wanted to, but we'll get something out of this. So the 2x's are opposite signs, so I can't fix anything there. And in fact, I can't get rid of either of them. So I'm going to cancel here, and here, and here, and here. And it's not great, but it is what it is. My final answer, negative 2x minus 3, 2x plus 1, two different things, over x minus 1, 2x plus 3. The last one of this is to divide factorable fractions. So recalling that when we do division of two fractions, we are going to change the sign to multiplication and take the reciprocal or flip or invert the second fraction only. So it becomes AD over CB. Now people are like, can't you just cross multiply here? You can, but you have to remember that this goes to the numerator and this goes to the denominator. So whatever works for you, I just like to do it that way. So looking at our example here, we have N1, oops, let's switch to this. There we go. N1 over D1. And looking at our second fraction, I'm going to do something, I'm going to change things just so I don't have to rewrite as much in this small space. So I know that this is going to invert, and this will be the denominator when I invert and multiply, and this will be the numerator. Do it whatever way you want. You can set it all up, factor and flip, whatever works for you. So let's switch my colors and then go to N1. Not common factorable, so here we go. AC line, negative 4. And you may see ways to do this like just by looking. That's fine. I'm just trying to be consistent in my method. So I have 2x and 2x as my kind of fraction tops, But first I forgot to factor it. So let's do this, and we're going to do 4 times 1 to get 3 apart, where the 4 is positive and the 1 is negative, and that works. So we're going to do 4 and negative 1. This one can reduce to 1 over 2. So a little messy here, but for numerator 1, I'm going to get x plus 2 onto 2x minus 1. Okay, denominator 1, I'm going to take out a negative because I see the x squared term is negative, and I'm going to flip it around. So I'm going to have 2x squared minus 3x minus 2. And that's what I'm going to factor the same way. So my AC line, once again, negative 4, and my B line, negative 3. So same 2 factors, except this time the 4 is negative and the 1 is positive. So just kind of shortcutting things. I know that this time I will have x minus 2 and 2x plus 1. Take as long as you need on these. Okay, the thing that's going to become n2 is 4x plus 2. Remember that. So we're going to take out 2 there, and we're going to be left with 2x plus 1. And the thing that'll become d2 when we flip will be 5x plus 10, and I can take out a 5 there and have x plus 2. So just looking at these numbers here so I don't get distracted by the picture when I'm rearranging this, and I'm going to switch to a color that I can write on black with because it's going to be big. So our n1, x plus 2, 2x minus 1, our n2, I'm going to take the 2, put in the front so I don't lose it, and then 2x plus 1. All of that over d1, which is x minus 2, 2x plus 1, okay, and then the 5, and another x plus 2. So canceling, green show up, yeah, okay. So x plus 2 is out, 2x plus 1 is out. The 2 and the 5 don't reduce, nor do those binomials. Final answer, 2 onto 2x minus 1 over 5 onto x minus 2. Couple more examples. Here we go. So while I'm here, n1, d1, and when they flip, this will be n2, and this will be d2. Okay, for n1, common factoring, nice and easy. Can take out an x, x onto x minus 1. For d1, common factoring, sweet. Take out a 3 onto x plus 3. For d2, or n2 rather, sorry. This looks like a difference of squares. It's kind of wonky, so I'm going to take out a negative 2 to get that leading term positive. And I'm going to put the x squared back in front. Look at that. That's a difference of squares. X minus 3, x plus 3. And for what will become d2, that's simple factoring, so I need to make 1, but simultaneously add to negative 2, so it has to be x minus 1 squared, or x minus 1 times x minus 1. Put them all together. All the numerators go together, n1, n2, put the negative 2 in front so I don't lose it. Then we're going to put all the denominators together. 3 onto x plus 3, and x minus 1, and another x minus 1. Getting out your canceling pen. I can cancel here, and I can cancel here. And I can't do much with that x, and I can't do much with those numbers, so I'm going to say the final answer is negative 2x onto x minus 3, and then 3 onto x minus 1. very, very, very last one. Bit of a doozy. Okay. N1, D1. When I flip the fraction to multiply, this will become N2. This will become D2. All right. I feel like I'm going to start here because it's going to be massive. N1 has a common factor. I can take 2 out, and I'm left with 3x squared minus, 2x minus 8. So the deal is I'm going to do factoring with the stuff in the bracket. So I need to, for my AC line, multiply to negative 24 and be 2 apart, or combine to negative 2. And the ones that are going to do that for me are 6 and 4 with the 6 negative. Write down your A value twice, that 3, and then an x after it, and the 2 factors you just found. Cancel if you can. Second fraction, no. First fraction, this could be equivalent to this. And so for N1, we get x minus 2 over, onto 3x plus 4. Okay, D1. Oof. That one's easy, so I'm going to put it here and hope I find it later. Okay, I need to multiply to 14 and combine to negative 9, x minus 7 onto x minus 2. All right, N2, also not terrible, gets to go here. Factor out that negative, and you have a difference of squares, x squared minus 49, so you have x minus 7, x plus 7. And D2, ugh, all right, here we go. What can I factor out of this? I can factor a 2 out only. And I'm left with x squared, 3x squared again. And we're going to have plus 25x, and plus 28. Okay, so my AC line is going to be a little bit terrible. I need to multiply to 28 times 3, which is 84. Okay, a few things make 84. And I need to add to 25. So maybe you have to think about it for a while, or maybe you just got lucky and 21 times 4 came into your head. There's no shame in punching the calculator. So let's do the reduction here. One of them is over 21, and one of them is over 4. The 1 over 4 can't reduce, but this one can be the same as 1 over 7. I'm going to build everything to start right here. So N1. I'm going to highlight all my things so I don't lose them. I didn't even finish D2. Better write that down. So for finished product on D2, which now is not going to be highlighted, x plus 7, 3x plus 4. All right, let's see if I find everything. So N1, x minus 2, 3x plus 4. N2, there's a negative, I'm going to put in front. X minus 7, x plus 7. D1, after I draw my beautiful line, x minus 7, x minus 2. D2, x plus 7, 3x plus 4. And you know what I did forget? And this is super classic. I forgot the things I factored out. At the end of the day, it's not going to make a big difference, but I should put them back in because that is not always the case. So watch out for leaving things behind. That is my classic move. All right, 3x plus 4, 3x plus 4. Hey, check it out. And I'm kind of at this point, negative 2 over 2, which is equal to negative 1. There you go. That's a massive simplification.